Yeah, look at this one. I modified a little bit, but I need to add a few more features. Yeah. All right. So you can see we still work on the university database. Yeah. And remember the example code I give you. Yeah. So that's your starting point. Yeah. And here you can see we do not have that sort version. Yeah. Do not have that sort version. Yeah. Yeah. I may like to keep that sort version. I may like to keep that sort version. So you start from that two-way sorting. Remember, we have a case study 1, 2, 3. Case study number 3. Let us use that one as our starting point. Okay, yeah, starting point. After that, here, this is the old version. This one, the title, insert new data into university database. But I want to add insert, update, delete data into in this database, in university database. Insert, update, and delete. And we do those 3 things. Yeah. And here, this is the insert version. Yeah, that's simple. So at the bottom part, we add some input fields. And there is an add button. When you click it, you insert one row into this table. And we have 5 tables. You can go to different tables and do insertion like that. Okay, yeah. So that is the first feature. Yeah. And in this old project, it's done. But I feel that's too easy, right? For our first project, if we only do that insertion feature, that's probably too easy for you. So I like to add 2 more features. Update and delete. Update, you need to do slightly more. Okay, yeah, because update, so look at that. What do we need to do to update one row? In any selected table, you can update any row. Yeah. So here I may like to, associate edit button for each row. How do you select a row? Think about how do you select a row? One way to do the selection, you associate each row an edit button. Edit button. Okay. So when you click the edit button, then the data for that row is pulled and displayed in the editing area, editing place. Yeah. So we can use the bottom part for the editing case. Yeah. So all data display in those text fields, input fields. But this time, you will change the button to update. Here the add button becomes update button because you want to update that row, old data, that row. So the user can change data anywhere in those input fields, any input field. Okay, then click the update button, you edit it. All right. So similarly, delete feature, you just associate each row a delete button. When you click it, that row is gone. That's it. Yeah, easier than edit. Yeah. So here it looks like the editing part relatively hard. You need to do more work, okay? You need to make selection first, then pull the data next, then, you know, change, update. After the update, then you know, do one update query to make the change. Yeah. All right, so those things we put together in this project. Then I feel for our project number 1, that should be good enough. Okay, so you practice, you know, some basic things, although basic things, but you need to do some work. Yeah, in the process, when you work, you know, implement these features, you can learn something. You can get some experience. All right, yeah. And here, there is a technical thing. Yeah, actually, the technical thing I will also discuss in today's lecture. Today's lecture, actually, we talk about insert, update, delete. Yeah, actually, delete. Yeah, I didn't talk about delete because delete so simple. Delete, we do not really need to do a lot of work. So delete is very simple. Yeah. Insertion and update, you know, there are a few things we need to study. Yeah. Relatively easy, much easier than selection case. And in this project, we do not do select statements. Yeah, the select part we already have in our case study examples. Yeah, so we only do insertion and update. Okay, yeah, but there is one small technical problem we need to solve here. Yeah. That is when you make selection. Yeah, we associate a button to each row. The questions, how do you identify a row? In a given table, how do you identify each row? That is a little technical question. Yeah. Yeah. If you can answer that question, then the whole project won't be that hard. Yeah. So that one is relatively hard. The reason is to identify a row. If that table has a primary key, that's easy. You use the primary key to identify individual rows. But in our 5 tables, some of the tables we do not have primary keys. Look at that. Yeah. So let's take a look. Let me see if I have that database, University DB. Yeah, let me open it. Yeah. Let me open that university database. Okay. Yeah. In which module I use that? Module 2 or 3, I don't know. Yeah, not module 2, probably module 3. Yeah, I don't, oh, yeah. Because case study, I remember case study part, this one, I start case study. Yeah, all right. Yeah, it should be here. The first version, university view, I include that. Okay, yeah. Let me open this one in text editor. Yeah. All right. Primary key. Here, we need a primary key, right? Yeah. You check course. We do not see primary key, right? Section, we do not see primary key. Yeah, let's take a look. All right, yeah, let's take a look. Student, Student number, primary key, yeah, okay. We define at the bottom. Alter table course, add primary key, course number, yeah, that's the primary key for course. Section, we also have primary key. Student, we have, you can see 3 of the 5 tables, we have primary keys. Course, section, and student. These 3 tables. Then the remaining, we don't have primary keys. All right, yeah, remaining. Look at this one. Grade underscore report. This one, we don't have primary key, right? Yeah, we don't have that primary key. Okay, yeah. Then look at prerequisite. Look at this table, prerequisite. We don't have that primary key. Okay, yeah. Yeah, 2 of the 5 tables, we don't have primary keys. Now the question, in order to make selection for editing or deletion, those 2 operations, we need to identify individual rows without primary keys. Think about that. How to solve that technical question. All right? If you can solve that technical questions, then we can do it. We can solve the problem. All right. Yeah. So that is a small technical question. All right. Yeah. Yeah. All right. So I can find the solution, and I will talk about that sometime later. Yeah. All right. Okay. Yeah. So today, after I go back, I will update this description, adding 2 more features, editing and deletion. You know, then I modify my description slightly. Yeah, yeah. And then I post. Okay, I post. So we treat the starting date is tomorrow. Okay, tomorrow. Then I will give you 4 weeks to complete it. So the due date, November 10th, Thursday, that is 4 weeks from tomorrow, all right? November 10th, Thursday, that is 4 weeks from tomorrow, Thursday, okay? Yeah, all right. So that is our first project. Okay, yeah. Yeah, today, I will talk a little bit, in my lecture, there is a place I talk about, you know, primary key, no primary key, you know, how to identify a row. All right. Okay, yeah, let me start today's lecture. Yeah. So last time, although I include insert statement, but I didn't have time to cover it. So I move it here. Yeah. I move the insert part of the previous lecture. Yeah. So in module, what's that? Yeah, still module 4. Module 4 part A, part B. Yeah. Yeah, last time part B. So I move the last topic, B.4 something. Yeah, I move that one to the C part. So yeah, so we do not need to look at that part of B part. So today, part of C, we do insert and update statements. Yeah. All right, so let me talk about the things we need to pay attention for these 2 types of query statements. Yeah. Much easier than select statements. Yeah. So after today's lecture, we won't talk about these 2 types of statements anymore. So the remaining time we all spend on select statements. All right. Part C.1, insert statement. So let us look at a few cases when we do insert statements. All right. First, let's look at its simplest form. Insert is used to add a single. Yeah. Our first version, we only need to add one tuple into the relation, one tuple into the table. Yeah. In a straightforward way. Yeah. All right. So we must specify the relation name and the list of values for the tuple. All right. The values should be listed in the same order in which the corresponding attributes were specified in the create table command. Here, the order is important. Yeah. You have to use the same order. Yeah. In this version, we do not specify attributes another time. Okay. So in this, our first version, we only provide values. Yeah. So the attributes in the original order, we just use the original one in the table definition. Yeah. So let's look at example. This is the example. Okay. Yeah. So in this example, insert into employee table, you can see after employee table, we do not specify all the attribute names in the original order. If we do not do that, by default, we take the table definition order. And for all the attributes, we include all the attributes here. Here you can see in that way, we do not need to type that part of information. Okay, all right. So you only need to provide values. Then when you write the values, be careful using the same order. Okay, yeah. All right, so first name, last name, mid name. Yeah, yeah. All right, yeah, first, mid, last, Social Security SSN, date of birth, address, yeah, so sex, and salary, right? Salary, supervisor SSN, right? And the department number, yeah. So based on that information, you can make one insertion for one tuple, one row into the table. Yeah, that's simple, that's straightforward. But this is the first version. After that, we have a few more different versions. All right, so let's look at next version. Second form of insert operation. This version, we allow the user to specify explicit attribute names that correspond to the values provided in the insert command. Explicit. So this time, we may not include all attributes. We may only include some of the attributes. Yeah. You do not need to list all of them. Okay. All right. So you can choose some of the attributes. All right. Yeah. So that's one place you have some freedom to write your insert statement. Another place to write your insert statement, you can choose the order you like. You do not have to use the original order. So you have a little freedom in the way you write your data in the in any order you like. Yeah. So you can choose your order for these attributes. Okay, yeah. So that's the small freedom you can have. All right. But you need to, when you write in this version, still you need to pay attention to a few places. Yeah. All right, so here, the first thing you need to pay attention, yeah, the values must include all attributes with not null specification. Yeah. Some of the fields in the definition, you do not allow them to take null values. So not nulls, constraint, okay? And no default value. So look at that requirement. All right. Think about, for one attribute, you make this kind of special definition or declaration like this. All right. Not null. Yeah. First, you put not null constraint. Okay. Second, after not null, you do not provide default value. If you have these both conditions satisfied, then when you do the insertion, you have to include that attribute in your list. You cannot skip it. You cannot skip it. If you skip it, your insert statement would have an error. Would have an error. So you can understand this rule by logic. By logic. Right? Yeah. So let's look at another one. All right. Attributes with null allowed or default values are the ones that can be left out. Yeah. In these two cases, you can leave out those attributes. First, you do not put not null constraint. You do not put the not null constraint on that attribute. If you, in this case, if you do not include that attribute in your insert statement, then the null value will be used. So there won't be an error. No error. Right? All right. So because null value is allowed. So that's the first case. Second case, default value. All right. So even if you have the not null constraint, you have a chance to provide its default value. You use default clause to specify that default value. Okay, the default keyword, provide default value. In that way, the default value will be used. Yeah. So not null or not null, you can always provide default value, right? Only in those two cases, you can leave out those attributes. Yeah. So here, that's the basic rules. Yeah. All right. So that means you need to check a little bit before you run your insert statement. You need to make sure these things are all right. Yeah. Look at this example. Still in our employee table. This time, we want to provide data for these four attributes: F name, L name, Dino, SSN. Okay. All the remaining attributes, we leave them out. Okay. Like, mid name, right? Yeah. Middle name. middle initial, yeah, middle initial. Yeah. All right. It could be null, right? Or it could take the default value, okay? Yeah. And birthday, yeah, birth date. That date could be left out. So then either null value or default value. Okay, yeah. Supervisor social security number not provided. So that could be null, yeah, probably not default value, right? Yeah, null, yeah, and so on. Okay, yeah, yeah, and you can choose the order you like, so you do not have to follow the original order. Yeah, but when you choose a different order to write out your attributes, make sure the data match the order that correspond to the attribute order. Okay, do not mess up. Do not, arrange the data in a different way. Yeah, not matching quite right to the order of your attributes. Yeah. So after those little things you really pay attention to, you won't have any problem for the insert statement. All right, so that is the second version. Okay. Then let's look at a few more other versions. Yeah. C.2, insert multiple tuples. If every time we just insert one single row, it won't be efficient. We want to do our insertion operation more efficient, because when we manage our database, manage our business data in our database, many times we need to insert a large number of rows. That happens frequently. Okay, import, export. So we need to manipulate on large number of rows. That kind of situation. So we consider efficiency issue here. Yeah. All right. So first, let's take a look how to insert multiple rows in a table. Yeah. All right. In a single command. Here, we emphasize one command to do multiple row insertion. Yeah. If multiple commands, then so you do not need to do anything special. So you just repeat the single command version again and again. All right. But that way won't be efficient. The reason that's not a good way, because it will be relatively slow. It won't be efficient. Yeah. So we want to do the most efficient way. Yeah. So let's consider the multiple row insertion. It is also possible to insert into a relation multiple tuples separated by comma. Yes, you can write multiple rows in one statement. The only way you tell the DBMS to separate different rows, just use commas. Commas. Okay, row 1, row 2, row 3, a sequence of rows in one statement. That's simple. Okay, yeah. All right. The attribute values forming each tuple are enclosed in parentheses. Then the tuple, we know, usually we use a pair of parentheses to write standard tuple notation. Okay, yeah. So you use the same way to write a standard tuple. notation. Yeah. Look at this example. Here, first, although we use multiple lines, but you can see this is one single insert statement. Because you write this insert into only once, at the end, you only have one semicolon. That means one insert statement. In the middle, you have many rows, but you use comma to separate those rows. That's simple. Okay, yeah. And it is okay, you use, you put all rows in one line. It is okay, no problem. But here, we put each line only one row for better readability, right? Yeah. So if you put in one row, all data in one row, it is quite hard to identify those different rows. And in this way, it is much easier to identify different rows. Yeah. For better readability. Yeah. All right. Then, in this way, you run this one statement, you insert all these rows at the same time. Yeah, even one after another, but still, the performance of this command will be significantly faster than the way you do single command insertion on these rows. Let me count, 2, 4, 6. On these 6 rows, on 6 single command times, that will be significantly slower. All right? Yeah. So you may ask why significantly slower. The reason is simple. The reason is, because in this way, you can reduce the overhead part. There is the overhead part. Yeah. In DBMS, to execute one statement, you need to do preparation, right? Yeah. To execute one statement, there is a preparation part. Yeah. So let's treat, this part setup, the preparation, the setup part. Okay. All right. If you use the single command version for each command, you need to spend some time on the setup part. Yeah. 6 commands, you need to spend the overhead setup part 6 times. But here, we use one command to insert 6 rows, so we only spend the setup part once. Okay, only once. And the remaining, because after that one setup, you can do the work, insertion work on 6 rows consecutively. Okay, yeah. So comparing, you spend setup part 6 times, so you waste 5 times. Think about that. You waste the setup preparation part 5 times. Now, when the row numbers relatively big, hundreds of rows, think about hundreds of rows, you need to waste that setup time hundreds of times. That's a lot. Think about that. That's a lot. Okay. All right. So you get a point. The reason we can save a lot of time in this way, multiple row insertion. Yeah. All right. Next topic, batch insertion. Yes. Now you understand. Yeah. People tend to do batch insertion to save more time. Batch insertion. Prepare your insert statement in batch. In batch. Okay? Yeah. Batch. That means a block of rows. One batch. Yeah. How many rows one batch contains? Yeah. That number will depend on DBMS. Yeah. So the DBMS will make that decision. How many rows should be placed in one batch? There is a limit for the batch definition. There is a limit. Okay? Yeah. Yeah. For batch. Yeah. So then within that limit, you want to put the maximum number of rows. The more rows you put it within the batch limit, the more time you can save. Okay? The more time you can save. All right. Yeah. Here, let me use the Java JDBC to explain how to do the batch insertion in application programs. Application programs. Okay, yeah. All right. All right. So in Java, my example, in Java format, first, we define our query string, first row, okay? Those three question marks, we need to provide values for 3 attributes. Yeah. But the values are unknown, so we use question mark first in the preparation. Then we need to create a connection object. In the connection object, we call this getConnection method. Okay, so that is the user-defined method. Okay, yeah. In JDBC, we know how to do the database connection. Yeah. So we put a JDBC database connection code in this getConnection method. Yeah. But pretty much standard. Yeah. The code there pretty much standard. Yeah. We just copy paste and put there. All right. Yeah. Here I skipped that part. Yeah. Then we use prepared statement. So we compile. So this line, we compile the query command. Yeah. We call it pre-compilation. Let's continue. Yeah. All right. So here I'm talking about pre-compilation on the SQL command with unknown parameters. All right. Yeah. After that, later we will provide those parameters to make them known. Okay. All right. Yeah. So next. Oh, I need to, my remote control doesn't work. Let me just restart it. All right, then, yeah, it works. I need to restart it. All right. Next, now, before we run the batch insertion, we need to define batch size. Here, 1,000. 1,000. That's pretty much the usual batch size. Okay, about 1,000. Yeah. So 1,000 batch size, near 1,000 usually. Yeah. All right. Next, we need to use a for loop to run our batch insertion. So in that for loop, you add your data row by row. Okay, yeah. So you fill in, oh, I need to change the color. All right, okay. For each row, that is one row data, okay? One row, you have 3 question marks. So 1, 2, 3. You provide data name for the question mark number 1, city for question mark number 2, phone for question mark number 3. After that, you add batch. All right. Don't do the insertion yet. We just prepare our current batch. All right. Add it to the batch. As a buffer, we buffer it in the batch. All right. So 1, 2, 3. We put 1,000 rows in one batch. After that, we run that batch as one single insert statement. Then ps dot execute batch method. This time, 1,000 row insertion, we only need to use one setup overhead. Look at that. Look at the amount of time you can save in this batch insertion. All right. Yeah. Setup. So look at, you use one setup time. And do 1,000 row insertion in this batch. You can see you save 999 setup time. How about that? Setup time. Think about that. Quite a lot. You save. So that's the reason. Yeah. For large number of row insertions, people do batch insertion. Okay. Yeah. In PHP, we can also do batch insertion. Yeah. Yeah. So, you know, yeah. We just in PHP, we do not do the Java way. We use the PHP way. You just prepare a long insertion statement. Yeah. You can construct a string, use a for loop. You know, you construct a long insertion statement. Then you execute that statement. That's the batch insertion. Yeah. Java here, it provides API, special API feature for batch insertion. PHP, you do not need a special API support. You just prepare long insertion statement and run it, execute that long statement. You can do the same thing, yeah, because that is just one single insert statement. Yeah. All right, so we complete this special case. Yeah. All right, yeah, this code we have, you know, the remaining part. Yeah. All right. Yeah, because, yeah, so for the batch, insert remaining, sometimes after you put the, you know, in the batch, you may have some more rows, right? More rows, then you need to complete it. Yeah. Anyway, so here you just get an idea, okay? Get an idea how to do the batch insertion. Yeah. All right. Okay. Yeah. Yeah, because here, right, we do the batch size, but after the batch size, you may have extra, right? Yeah. So, all right. C.3, insert tuples from a query result. Yeah, another special situation. We can do the insert statement. This time, we get our data from a query result. Okay, yeah, our data comes from a query result. Then we insert that data directly to another relation. Yeah. So let's look at this variation. Yeah. So this special type insert command inserts multiple tuples into a relation in conjunction with creating the relation and loading it with the result of query. Yeah. Create it, yeah, you can do that, but that's optional. Yeah. You can insert in an existing relation. Yeah. New relation, existing relation. Yeah, just two different options for you. Yeah. We just look at the second part. Using the data from the result of some query. Yeah, here, the first part, in our company database, we create a new table. Now, this is a new table with name works_on_info. Yeah. So then you define in this way. So this is your table definition. Okay. Yeah. After that, then we can do insertion. But we want to do efficient insertion. So not row by row. We want to do multiple row insertion at the same time. Yeah. So here, let's look at our insert statement. Insert into this table the attribute list, column list, yeah, in this way. All right, yeah. Okay, yeah. 1, 2, 3, yeah. Then you provide a query result, select statement. That is the query result. Look at that. Okay, that's the table join operation we did last time. Yeah, and not exactly last time. We learned last time. We joined 3 tables here. Okay, a project, works_on, and employee, 3 tables. Yeah. So after we join them, we derive the data. The data created in this table, derived the data, not original data, derived the data. So then we just insert all the rows of our query result into our new table. But it also works. Yeah. So you have this version of insert statement. Okay. Yeah. So sometimes you may like to use this version. Yeah. That pretty much covers all the, not all, we just say most frequently used cases for our insert statements. Yeah. Should be good enough for 90-something% of the time. Yeah, these versions should be enough. Okay. Yeah. All right. So we complete our insert statement. Next, update statements. Yeah. Update, yeah, even simpler than insert statement. Yeah. Insert, we have that many cases. But update, fewer cases. All right. The general case update. The syntax, update table name. Then set clause, you specify individual field values, the values you want to update for those fields, columns. Column 1 equals value 1, comma, separated by commas. Yeah. All right. Yeah. Then where condition. You provide appropriate condition to, make sure the rows you do updates are correct. Yeah. So that's the general case. Yeah. With and without primary keys. Now, this is the question related to our project. Right? In our project, we have 5 tables, 3 of them with primary keys, but 2 of them without primary keys. So here we need to look at that question. With primary key, that's straightforward, right? In your condition, you use the primary keys in that condition. It will be very easy to identify individual rows with primary keys. All right, yeah. All right. With a primary key, that's easy. Yeah. Straightforward. So that's our preferred case. We like to have primary keys. So here you can understand the importance of primary keys. Yeah. Otherwise, when you do updates, you need to do a lot of work. You need to do quite some work to identify those rows. Okay, all right. Without any primary key, then one way to identify rows with the row number. Yeah, but you need a DBMS to support this feature. All right. So here, the row number way to identify rows, you need DBMS support here. Some DBMS is supported, but some do not support. Some do not support. Then you need to find a different solution. Okay, yeah, all right. So here, look at the version. Yeah, this is one possible version. Yeah. So we do the update, but the remaining part, we assume this table does not have any primary key. So we need to use row number to identify it. Yeah. Here, limit, here it looks like the MySQL case. Yeah, because we use the limit keyword. Yeah. Then row count. You can use row count to control those rows. Yeah. All right. Those rows, row count. Yeah. Yeah. That may not be convenient, this row count, because how do you know your row count is correct, right? How do you know your row count is correct, right? Yes. If the order changes, then your row count will be messed up, right? Think about that technical problem. Yeah. If your row count is a stable control parameter, that question you need to answer, right? Yeah. So is this control stable? Is it a stable control, right? Yeah. You need to really do some examination here, all right? Yeah. Otherwise, you will update on the wrong row. Yeah, that will be disaster, right? Yeah. So you ruin your data. And that will be a big problem. Yeah. All right. So then DBMS with row number functions. Here I give you a few examples for the DBMS with row number function. SQL Server, Microsoft SQL Server has this function. Oracle has this function. For MySQL, the version should be 8.0 or later. For earlier version, no such function. Okay, earlier version, but still earlier versions earlier than 8.0 still used a lot. Okay, yeah, still on the market used a lot. So you can imagine that row count. Row number, yeah, not row count and the row number. Those two concepts still slightly different, all right? Still slightly different. Yeah. Probably a row number, that control more stable than row count, okay? Row number, yeah, yeah, more stable, yeah, than row count. Yeah, because row count can change easily, right? based on your query result, right? When your query result changes, the row count may be changed. But the row number, each table, there is a fixed row number, all right? Yeah, that won't change. Yeah, so you will have some row number. Yeah. But the question is, how do you know that row number, right? You need to figure out that row number, because usually people may not pay attention to that row number. How do you find that row number, right? So that part, you need to spend quite some effort. You need to make quite some effort to figure out the row number information. Yeah. All right. Yeah. In our project, yeah, probably the row number, row count won't be convenient to use. So in our project, we may try to use a different way to figure out, to identify, different way to identify the rows. Yeah. So that means this technical problem, not trivial, non-trivial, right? Yeah. So that will make this project slightly challenging for you. Okay, not so trivial. Yeah, you need to have the experience solving this small technical problem. That could be valuable for your real world. Later in the real world applications, you may have a chance to solve similar question, right? Yeah, here you have a chance to solve it in this class. Okay, we try to figure out. Yeah. All right. Yeah. Let me. I have a few more minutes. Let me talk about our last special case. Still update. Yeah. Part 2, special case. Updating a primary key value may propagate to the foreign key values of tuples in other relations if such a referential triggered action is specified. Here, there is this special case. You may have the performance bottleneck due to this reason. Yeah. So let me explain a little bit. Slow down performance. If this situation occurs, then your update could be very slow. Yeah. The reason, propagate thing. Yeah. Because when you update a primary key, but many other tables need to use this primary key value as their foreign keys. You need to, search all those tables and make the updates, everywhere when the foreign key is used. Okay, yeah. So that will be relatively slow. Yeah, sometimes could be pretty slow. Sometimes you can notice the delay. Yeah, significant long delay. Yeah, yeah. So that problem in your real world applications, you need to solve it. Yeah, otherwise, your customers won't be happy. Yeah, when this occurs, they need to wait quite a long time. All right, yeah, all right. So here, let me talk about a better way, yeah, to solve this problem. Yeah. One way that people frequently use to avoid this situation is use fixed internal auto increment primary key. Yeah. This is an artificial primary key. All right. Yeah. Artificial. Artificial, it means it does not come from the original business data. So we create this artificial data using the auto increment way to do it. Yeah. All right. The main reason to use it for convenience, because if we use this kind of artificial data, as the primary key because there is no business meaning for it. Okay, nothing to do with your business. All right, that means it is fixed. Yeah, you do not have the chance to update it. Yeah, remember the reason we have this slow performance problem when we need to update the primary key. The reason you update it because if the primary key is related to the business, you may have a chance to update it. But here, our artificial data has nothing to do with your business. So we have no chance to update it, right? Yeah. So that one usually we use the auto increment. For example, for this table, we call the problem table. In the problem table, we create a problem ID. In the original business data, there is no problem ID for it. We just use the auto increment way to generate artificial problem ID. Start from 1, 1, 2, 3, 4, and so on. Auto increment. Every time we increase this number by 1. All right, automatic. You do not need to specify it. It is increased automatically. Yeah. This feature is supported by MySQL. So very convenient. Okay. For other DBS, this feature may not be supported for other DBMS. So you need to find a different way to do it. Yeah. All right. And after you use this kind of auto increment primary key, later you do not need to change it. There is no reason to change it. Although you can, if you like, you can. But because it is, you know, there is no specific business meaning, special business meaning associated with it. Why you change it, right? Why this artificially created identification number is so important, right? So your problem called number 5, number 7, number 10, it's not that important, right? You only need different values. The specific number, that's not important, right? Yeah. So for that reason, after you create it, it is rare you need to change it. Okay? We do not say, you know, it is impossible. We just say it's rare you need to change these values. All right. So after that, then you have the primary keys, then your life will be much easier. Now, that's one popular way that people do in their database design. Based on my own experience, when I design my databases, I frequently use this kind of primary keys. Yeah. So, and I used for a long time, and my experience really good. Okay, I have no chance. I have no need to change them. Okay, yeah, it works well. You know, so it's rare. I need to change that. Yeah. All right. That's what I need to cover for these two query statements. 2 types: insert, update, query types. Yeah. All right, so let's complete part C of module 4 right here, and we will have the last part D, for this module C. No, the module 4. Yeah. All right, so I will post programming project number 1 sometime tonight. So you will see it sometime tomorrow morning. Yeah. So you can start, you know, do your planning. Yeah. Working